Welcome to this video on the stack data structure. In this video, we'll be exploring how the stack works and demonstrating its basic operations. Firstly, let's define what a stack is. A stack is a data structure that allows you to store and retrieve data in a specific way. It follows the last in, first out principle, which means the last item added to the stack is the first item that gets removed. Let's take an example of the stack data structure with a list of 3 items, item A, B, and C. The first basic operation of the stack data structure is the push operation. This operation adds an item to the top of the stack. So let's perform a push operation by pushing the item A onto our stack. As seen here, item A is added onto the stack. Now let's push item B and C. Now that all the items are pushed to the stack, we can see that B is added on top of A and C is added on top of B, making C the topmost item. The second basic operation of the stack data structure is the pop operation. This operation removes the topmost item from the stack. Let's pop an item from our stack. As you can see, the item C is removed from the stack. This is because it was the last item to be added, hence making it the topmost item. Now let's pop the other 2 items from the stack. We can see that the items were removed in a sequence, starting with B, then A, therefore following the last in, first out principle. The stack data structure arranges items in a stack, hence the name stack. This arrangement allows us to only add and remove items from the top of the stack, and that's how the stack data structure works. The push operation adds an item to the top of the stack, while the pop operation removes the topmost item. Now that we have covered the basics of the stack data structure, let's take a look at some examples of how the stack data structure is used in real-world applications. One use of the stack can be found in web browsers. Web browsers use the stack data structure to keep track of the pages you visit. Each time you visit a new page, it gets added to the top of the stack. When you press the back button, the topmost page is removed from the stack and you are taken back to the previous page. Another example can be seen in the undo and redo functions in applications. Many applications such as text editors or graphic design software provide the undo and redo function to allow users to easily revert the state of the application. These applications typically use the stack data structure to store the user's actions. When the user performs an action, it gets added to the top of the stack. When the user clicks the undo button, the topmost action is removed from the stack, therefore undoing the action. Another place where the stack data structure is used can be found in how computers execute instructions. When a program is executing on a computer, the computer uses what is called a call stack to keep track of the order in which functions are called. The call stack is simply a stack data structure. Each time a function is called during execution, it gets added to the top of the stack. When the function is done executing, it gets removed from the top of the stack and the program continues executing the previous function that was on top of that stack. This allows the program to keep track of where it is during the execution process and to return to the previous functions. So there you have it, some real-world examples of how the stack data structure is used. It's a simple yet powerful data structure that has many practical uses. Thanks for watching this video. I'll see you in the next one.